going to be talking about our equilibrium constants of reversible reactions. And we know that this is a reversible reaction because we see the double arrow here. Remember, the top arrow means the forward reaction, the bottom arrow means the reverse reaction. We generally call these our reactants and these are products, even though we know that it's going in both directions. So for an equilibrium constant to occur, or to be valid, the system has to be at equilibrium. So the rate of the forward reaction has to equal the rate of the reverse reaction. Okay? So that's the first thing that we need to know is occurring for these KEQs to be valid. Okay. So this KEQ, this is the equilibrium constant, KEQ. It is different from our lowercase k we mentioned before as our rate constant. So don't mix them up. They're completely different. They're not related in any way. So we generally state that our KEQ is the concentration of our products raised to the power of their coefficients divided by the concentration of the reactants raised to the power of their coefficients. So let me show you what that means. Here we've got the compound A adding to B and giving us compounds C and D. The lowercase are just numbers that are the coefficients used to balance the equation. So we have to have a balanced chemical equation before we get started here. Okay. So let's go ahead and do our KEQ. Our general formula for KEQ is the products, so it's the concentration of C, so uppercase C, raised to the power of its coefficient. Its coefficient is the lowercase c. Okay, so make sure those are differentiated. They look different. We're going to multiply it by the concentration of our other product, D, raised to the power of its coefficient. And on the bottom, we've got the concentration of A, raised to the power of its coefficient, times the concentration of B, raised to the power of its coefficient. So you can see this, the pattern that's arising. You can have multiple products, more than 3. You can have more reactants, or you can only have one. But the pattern stays the same. Products are on the top, reactants are on the bottom. You always raise the concentration to the power of its coefficient. Okay? And we'll do some examples so that you actually see what's going on there. A couple things we need to know, though, before we move on. For these KEQs to be valid, we need a balanced equation. The square brackets do mean molar concentrations. That's molarity, moles per liter, moles of solute per liter of solution. Remember, the products are always on top. The reactants are the ones on the bottom. If you flip them, you're going to get the wrong answer. So be careful about that. The other thing that we haven't mentioned yet, which is extremely critical, is that only the gases and the things in solutions, the AQs, will be included. If it has a subscript of an S or an L, we leave it out. And the reason is because the concentrations, even if you take a little bit of S or a solid or a liquid out, it's still not going to change the concentration of that particular thing because they're so concentrated. So if it's an S or an L, just leave it out. If you want, you can put a 1 there instead, if that helps you. For instance, say C and D were both solids. So we go ahead and the gas that's A gets put in and an AQ that's B gets put in. You have to have something up there, so you put a 1 there to make sure that you say that everything on all the products are solids or liquids, so you don't have anything there. Okay. So do remember, leave out the S's and the L's subscripts. Okay. Now let's go ahead and do some examples so we can practice putting this to real problems. Now here we've got a balanced chemical equation, and we're asked for what's the KEQ. Now when you're asked what's the KEQ, they're not necessarily looking for a number all the time. They're asking for the expression. Now if they give you numbers to plug into the expression, by all means do the calculation. But if there are no numbers there, don't think like you have to have a number. Okay? We're going to do the KEQ. Remember, it's products over reactants. So this is balanced, so all of our coefficients happen to be 1. Okay? So this is the straightforward, simplest problem possible. They are all gases, so they will all be in the KEQ. So we're going to take our products, so that's the concentration of CO2 raised to the power of its coefficient, which is 1, times the next product raised to the power of its coefficient, which is 1, divided by the reactant, CO, raised to the power of its coefficient, which is 1, times the concentration of H2O, because it's in gas form, raised to the power of its coefficient, which is 1. Now, raising to the first power is basically the same as just having the number. So if you're raising to a power of 1, you can leave the power out. But if there's anything else as a coefficient, make sure it gets as the superscript there. Okay. Let's try another one. Now this one's a simple one too. All the coefficients for the balanced equation are 1. However, this time we have one that is a liquid. So the AQ fits, but the liquid has to be left out. Here's another AQ and another AQ. Okay. So let's do the KEQ, and we only put the gases and the AQs in there. So we've got our product. This is our product, our concentration of our HCH3,3N plus. Don't forget the plus because that's part of the chemical name. Raised to the power of its coefficient, which is 1, times the hydroxide concentration, raised to the power of its coefficient, which is 1, divided by concentration of this reactant, CH3, with a subscript of 3 and an N, raised to the power of its coefficient, which is a 1, and that's it because we leave this guy out. Okay. So this would be the KEQ for this particular reversible reaction at equilibrium. Now let's try one that doesn't have 1 as coefficients for everything. Here we've got a reaction where we've got this gas, and then we've got I2 as a gas, and we've got HI as a gas. Okay, but note, the coefficients aren't all 1, so we've got to watch out for that. So we're going to write our KEQ. Remember, it's the products. We only have one product here. So it's HI, the concentration of HI, raised to the power of its coefficient, which means we square this. Okay, that's what the 2 means. We square it. And on the bottom, we have the concentration of the reactants, H2, raised to the power of its coefficient, which is 1. And then we've got I2, raised to the power of its coefficient, which is 1. Okay, so this is a general expression for the KEQ. Now, say we're told that, hey, this reaction is at 25 degrees Celsius, and this is the concentration of the H2, this is the concentration of the I2, this is the concentration of the HI, and we're asked, what is the actual KEQ? Because remember, KEQ is a number, right, after all. So we can actually plug those numbers in. Be careful when you're plugging it in to make sure you get the right thing. Here's the concentration of HI, 0.76 molar, but it's squared. Okay, so don't forget to square it. The concentration of H, 0.025 molar, and the concentration of I is 0.42 molar. This is the only problem where I'm going to tell you it's okay to drop your units. Okay, because depending upon how many products you've got, how many reactants you have, and what powers you have to raise them to, you're going to get all sorts of different types of units here. And so this is the one time it's okay to drop your units. Okay, but this is the only time you're going to hear me say this in the entire class. So let's go ahead and plug these guys into our calculator and see what we get. We're going to take 0.76, and we have to square it. Okay, so square that, and we're going to divide it by 0.025 divided by 0.42, and we get 55 with 2 significant figures, so 55 as our answer. Okay. So the KEQ at this temperature happens to be this. We can, say we can add some HI to the system, and we can disrupt it and change the concentrations of everything. But the KEQ stays valid. even if you change the concentrations of your things. This KEQ is valid at that temperature. The only time the KEQ would not be valid is if you change the temperature. Okay. Then you have a new KEQ that you have to calculate. But because of that, you can also do a calculation in reverse. If you're given this as the KEQ, and you're given all but one of these guys, you can go back and calculate that concentration. Remember, it's a matter of just algebra. You can use X, Y, and Z if you're more comfortable with those, rather than the concentration of HI, the concentration of H2, concentration of I2. So this is just a math problem. You've got 1, 2, 3, 4 different variables. If you have 3 of them, you can solve for the 4th. Now do note that you do have to go use your power buttons. And likewise, you may have to do the roots. Make sure you know how to do those in your calculator, because they may not always be 1 and 2. They may be, 5, 6, 8. If you have to take the 8th power of something, you want to know that you can do that on your calculator. Or if you have to take the 8th root of something, you want to know that you can do that on your calculator. So do watch that, figure that out. If you need help, reach out to me and we'll figure out your calculators as well.